Professor Baldwin here, and today we're going to cover systems of equations, but nonlinear systems of equations. So the equations we're going to have aren't going to be lines, or at least one of them will not be a line. Remember that a solution are any points of intersection, and they're going to be ordered pairs. We're going to deal with just two equations, so we're just going to have an x and a y coordinate. Systems of nonlinear equations can be found with substitution or elimination. I tend to use the substitution method. In example 1, we have these two equations. We have a circle and we have a line. I say we rewrite the line in terms of y equals 1 plus x, and then we can substitute it in to our first equation, the circle, and solve. So substituting in, we have x squared plus y squared, but y is now 1 plus x, and that's equal to 25. We keep the x squared. When we square 1 plus x, we get plus 1 plus 2x plus x squared, and that's equal to 25. Let's combine our like terms to get 2x squared plus 2x plus 1 equals 25. Let's bring this 25 over to the left-hand side and see if we can factor this. So we'll subtract 25 from both sides, and we have 2x squared plus 2x minus 24 equals 0. Well, we definitely have a GCF of 2, so factor out the GCF of 2, and we have x squared plus x minus 12 equals 0. Now, if you divide both sides by that GCF of 2, notice that the 2 simplifies out on the left, so we have x squared plus x minus 12 on the left. And on the right, you have 0 divided by 2, and 0 divided by anything is 0. So we're just left with this polynomial that we need to factor, and I'm pretty confident that we can factor this into two binomials. Two numbers that multiply to negative 12 and add to a positive 1. Well, 4 and 3 give me 12. If the 4 is positive and the 3 is negative, they multiply to a negative 12 and they add to a positive 1. Apply the zero product property, so x plus 4 equals 0 and x minus 3 equals 0. And you get the solutions that x equal negative 4 and x equals 3. But we're not done here. Remember, we're trying to find the solution to a system, which means we need x, y pairs. We have an x, so we want to go back to our original equations, pick one of them, and find y. Remember, it doesn't matter which one you pick, so pick the easier equation to work with, which here is that linear equation. So we're going to use y minus x equals 1. When x equals negative 4, we have y minus negative 4 equals 1, or y plus 4 equals 1. Subtract the 4 from both sides, and you get y equals negative 3. So this gave us the point negative 4, negative 3. Now when x is 3, we have y minus 3 equals 1. Add the 3, and we get y equals 4. That gives us the point 3 for x and 4 for y. So this system has 2 points of intersection, negative 4, negative 3, and 3, 4. Let's look at a more challenging problem. So here we have an ellipse and a hyperbola, and we want to use substitution again. I told you it's my favorite. And to do that, it's probably easiest to deal with the second equation. We can solve it for y and get y equals 6 over x. If we substitute that in, we have x squared plus our y, which is now 6 over x squared, equals 13. Okay, let's square what's in the parentheses. And we get 36 over x squared equals 13. Our brains absolutely hate fractions, so let's multiply everything by that common denominator of x squared. We'll get x to the fourth for our first term. The x squareds will simplify out and leave us with 36 for the second term, and it's equal to 13x squared on the right-hand side. Let's move that 13x squared over, because I'm starting to see what might be a polynomial. We have x to the fourth minus 13x squared plus 36 equals 0. It looks like a polynomial, right? Except that we have x to the fourth instead of x squared. So we can use u substitution and rewrite this as a quadratic. We're going to let u equal x squared. And by doing that, we get u squared minus 13u plus 36 equals 0. And we can factor this into two binomials. The first term is u for each, and two numbers that multiply to 36 but add to negative 13, that would be negative 9 and negative 4. You solve this with the zero product property and you'll get u equals 9 and u equals 4. But here we need to convert our u back into x, and it's x squared equals 9. Or x equals plus or minus 3. And for the second, it's x squared equals 4, or x equals plus or minus 2. So we're going to have four possibilities here. So we want to go back again to our given equations and pick the easier one to use. I say we use xy equals 6. And we need to do all four possibilities. So if x equals 3, we have 3 times y equals 6. Divide by 3, and y equals 2. Our first point then is 3, 2. If x equals negative 3, we have negative 3 times y equals 6. Divide by negative 3, and y equals negative 2. That would be the point negative 3, negative 2. Now with x equals plus or minus 2. We have x equals 2, or 2 times y equals 6. Divide by 2. So y equals 3. That's the point 2, 3. And lastly, x equals negative 2. That's negative 2 times y equals 6. Divide by negative 2. And y equals negative 3. And our final point then is negative 2, negative 3. So these two equations intersect at 4 places. Okay, very common with systems of equations, even nonlinear systems of equations, are word problems. Don't freak out when you see a word problem. Draw a picture, write what you know, and start fitting all the pieces together. So this application example, we're told Carrie's frame shop is framing 5 photos. Each photo has a perimeter of 68 inches and a diagonal of 26 inches. Find the dimensions of the photos. Okay, so we have a photo. And we know that a photo is going to have a width and a length. The first thing we're told is that the perimeter equals 68. So perimeter equals 68 inches. Well, perimeter is also found with the formula 2W plus 2L would equal 68. Well, notice that everything's divisible by 2. So if we divide everything by 2, we get our first equation of W plus L equals 34. Okay, the next thing we know, there's a diagonal of 26 inches. Well, that would mean that this is 26 inches. If this is a picture frame, we should have right angles. Well, when we drew that diagonal, we created a right triangle. And remember, Pythagorean theorem, a squared plus b squared equals the hypotenuse squared, or w squared plus length squared equals 26 squared. Let's write that out. W squared plus L squared and 26 squared is 676. So we have two equations now. I say we rewrite this first one in terms of W. So W equals 34 minus L. And we're going to substitute it into that second equation. So W squared. W is now 34 minus L, and it's squared, plus L squared equals 676. If you need to, write this first binomial out twice and use FOIL. You should get 1,156 minus 68L plus L squared. Then we have plus the other L squared equals 676. Let's combine like terms and put it all in descending order. We'll get 2L squared minus 68L plus 1,156 equals 676. Okay, these are some big numbers. Don't get overwhelmed. Just keep on plugging through. Use your calculator. We want to subtract 676 from both sides because we want to try to get this into something we can factor. So 2L squared minus 68L plus 480 equals 0. Now notice we have 2 for our leading coefficient, and our other two terms are also divisible by 2. Factor out the 2, and you have L squared minus 34L plus 240 equals 0. And remember, we can divide by 2 on both sides, and we're left with just this polynomial, or this quadratic, L squared minus 34L plus 240 equals 0. Now, I'm pretty sure that we can factor this. If you need to make some notes, but start with simple common factors. 240, we know it's going to be something times 10. 24 times 10? Well, in 24 plus 10 is 34. We need it to be negative, and if they're both negative, they multiply to a positive 240. Now we apply our zero product property. L minus 24 equals 0, and L minus 10 equals 0. Add 24 to both sides. The first one tells us length equals 24 inches, plus 10 gets added to both sides for the last equation, and length equals 10 inches. Now, length is usually the larger number. And with our equation, if you recall, we had width plus length had to equal 34. And here, if our length is 24, our width is 10. If we selected a length of 10, we'd get a width of 24. Really, it doesn't matter because we're asked for the dimensions, So the dimensions are 24 inches by 10 inches. See, that word problem wasn't that difficult. Just write down what you know and keep plugging through. And pictures always help. I hope this was helpful. If you still have a question or there's a problem that you want help with, please leave it in the comments and I'd be happy to make a video for you.